Yo, hello, my name is Wesbam and welcome to another V4 tutorial. Today we're going to look at the Arduino and how to quickly control it from VVVV and how to control V4 from the Arduino. I want to talk about the quick and easy way to use the Arduino and V4 using something called Firmata. I'm going to assume you have played a little bit with the Arduino, so I'm not going too deep in the details about the electronic setup. The Arduino I'm going to use is the most common one, the Arduino Uno, but it should work with any Arduino. But first, what is Firmata? Well, Firmata is a generic protocol that enables any computer to take full control over a microcontroller, like the Arduino. We can, on the fly, decide what pins we want to use as inputs or what pins will be the outputs. We can then read these pins or set these pins all inside VVVV. So we can read all kinds of sensors like buttons, potentiometers, light sensors or even distance sensors. And we can control stuff like LEDs, relays, piezo speakers or a servo engine. It has its limitations, but the coolest part is there is no need to write any code. Yes, that's right, we are not going to write any code at all. I will show you how to set up the Firmata and use VVVV to master the Arduino. So, let's get started and hook your Arduino up to your computer with a simple USB cable. It should install itself, so there is no need to download any drivers or whatever. Okay, next we are going to open the Arduino software. If everything went correct, you should see the Arduino here in the bottom right corner. It also says what COM port it is using, in my case it's COM port number 8, and we want to remember that for later when we are going to use VVVV. Firmata is basically an Arduino sketch, so we need to upload the Firmata sketch onto our Arduino board. And the sketch is the push word for the code we upload. The Firmata comes with the example sketches. So I click on File, Examples, and then down here you will see Firmata, and then we're gonna pick the standard Firmata. So nothing fancy, just the standard Firmata. Another Arduino screen will open, and this is all the code we're going to need and going to use. Now you can scroll through it and read all about it, try to understand it, but I'm not going to do that, I just want to upload it to my board. So I'm going to press the upload button. The software is first compiling the sketch, and then it says uploading, and if you look at your Arduino, you will see some LEDs blinking, and that means it's uploading. And once it's ready, it says done uploading, and we can close the Arduino software. And this is all. The Arduino is now running Firmata, and now we can start using it. But before we jump into VVVV, let's quickly look at the electronic components we are going to use. I got a breadboard set up with all kinds of sensors and reactors. As input, I will be showing a pot meter, a push button and a light sensor. The button and the light sensor have a 1000 ohm pull-down resistor. On the output side, I have a servo engine, a piezo speaker and a blue LED. The resistor I use for the LED is 330 ohms. The breadboard will get its power directly from the Arduino, so these and some jumper cables are all the parts that I will be using. So first, let's put some power on the breadboard power lines. A red one for the plus 5 volts and a black one for the ground. Okay, now it's time to jump into VVVV. The Firmata patch that comes packed with your VVVV installation. So, go to your VVVV installation folder, and in here we have a folder named Girl Power with all the example patches, and in here we have an EO folder for input-output that contains an Arduino folder, and in here we got a Arduino using Firmata patch. Now, if you have VVVV properly installed, you should just double left click on it and it will open automatically. Okay, this is the main patch for Firmata. Since I'm going to change everything, I'm just going to save this to a different location, so we can modify it without fear of losing the original. I press the middle mouse button, and in this menu I choose Save As, and then we're going to browse to a different location, and I'm going to save it. And now I have made a work copy. Let's firstly make an inspector, Ctrl-I on the keyboard, and let's put the inspector over here. And welcome to your Firmata main patch. Well, as you can see, there's a lot of text in here and you can all read it. I'm not going to read it out loud. I'm going to simply delete it because I need the space. Oh, and a quick tip, if you press the open button, your browser will open and it will guide you to the Arduino website where you got more information about your Arduino. But I'm not going to do that, so I just drag a square around it, hit the delete key. I'm not going to use the I2C or I2C function of the Firmata, so I'm just going to delete that as well. And now we got 2 exclamation marks, and these are rather important. This one says if you connect the Arduino while the patch is running, you should use her inspector to bang the update port list pin, and that way you can reconnect with your Arduino after a patch is started. So we know that, we can delete it. And the other one says that only one piece of software at a time can communicate with your Arduino. So be sure you close down your Arduino software before you open VVVV. So now we know, and now I can delete it. And here is my basic Arduino Firmata patch. Well, first things first, let me connect to my Arduino. I have to select a COM port. I double right click on the enum list and I can pick COM port 8. And now I can connect to the Arduino. So I hover above this pin and I right click, and now I'm connected to the Arduino. Okay, so what is this patch all about? Well, this patch is made to work with the Arduino Uno. And the Uno has 20 pins that we can use. Pins 0 to 13 are my digital pins, and analog 0 to analog 5 are my analog inputs. We can pick what a pin does by changing the enumeration for the corresponding pin. If I right click here on the first slice, I can choose what pin 1 will do from now on. We can set it up as a digital input, a digital output, an analog output, a PWM, a servo engine, a shift register, or I2C pin. Now I don't have a shift register and I don't have a I2C sensor, so we're not going to use the last two. The big thing you want to know about the Arduino is that not every pin can be set up to be any of these options. I mean, I can select them, but they're not going to work. The good news is it tells you all about it right here in the capabilities pin. Now it's a bit small, so let me scale up the pin and let me make the patch a bit bigger. And here you can read all the information about your Arduino board. Also, if you have more pins, like an Arduino Mega, you can see that here as well. Now, let's pretend you have an Arduino Mega. Well, that one comes with 54 digital and 16 analog pins, or a grand total of 70 pins. And in order to operate them, you have to change the spread count pin of this enumeration list. So I just click on it, and in her inspector over here, I can set the rows to 70. And now I got a long list of 70 pins. Or perhaps it's easier to read if you have 7 by 10 pins. And you can change all these pins if you got an Arduino Mega. Well, the Uno I am using only has 20, so I'm going to put everything back the way it was. 20 rows and 1 column. Next to the pin selection list, we have the values we can send to the Arduino. In VVVV, we're going to send every value from 0 to 1. So a digital 0 is a 0, a digital 1 is a 1, and the PWM of 70% is a value of 0.7. So not 70, just 0.7. And also please remember that, for example, if I connect a button to my Arduino and then I select that pin to be a digital input, the value that I typed over here will be ignored because this pin is set to an input and not as an output. So the Arduino will look for its values from the outside and not from the VVVV software. Okay, let's start simple. I'm going to hook up my servo engine. The black-brown wire goes to the ground, and the red one in the middle is the 5 volts, and the yellow-orange one is my signal. According to the capabilities list over here, I can stick my servo in any pin varying from pin number 3 to pin number 14. So let's pick pin number 3. And this is how easy you connect the servo, you don't need anything extra. Now all the hardware I'm using I got from a Arduino starters kit. It was about 50 euros, it came with an Arduino Uno and all the sensors, buttons and LEDs you see here. It's a very good investment if you want to learn about Arduino and electronics. Okay, so in the enumeration list I'm gonna set pin number 3 to be a servo pin. And now for the cool part. If I change value number 3, that's slice number 2, I'm going to change my servo engine. I can pick any value between 1 and 0 and my servo will rotate to that point and stay there. And here we see the power of Firmata. I did not write any code, decided the last second I wanted to use a servo on pin number 3, and yet here we are controlling the servo. I could now easily connect 12 servos to my Arduino and control them all with VVVV, just like that. But of course 12 servos will drain too much power of my Arduino, so if you decided to do that, make sure you use an external, proper power supply. Now, to keep things simple and safe, I will just unplug the servo and we can move on. I got a 10,000 ohm or 10K potentiometer over here, and I just soldered some headers on it so I can stick it in my breadboard. And the outer two pins are for the ground and 5 volts, and the middle pin will give me an analog signal. So if I stick the middle pin to analog 0, and the analog pin on the VVV side is already set. Now, to get any output, I should tell the Firmata plugin that I want some output. To do that, I need to enable the report analog pin. Now, I can right click and drag up and make it a 1. Or I can left click on it to make a connection and then middle mouse click, and then I got the proper I/O box already. And if I middle mouse click again, it even copies the name. And now I've told my Arduino board that I want to read some analog values connected to the analog pins. So let's see what happens if I turn my potentiometer. You see over here? Every time I turn the knob, I get a different value. Now if I hover above this pin, we will see a 6 between brackets, and that means we're dealing with a spread of 6 slices. 1 slice for every analog pin we want. Now, since my potentiometer is connected to the first analog pin, I only want the first value. Now, to get only one value of the spread I'm interested in, I will be using a get slice spread. So I double left click, start typing get slice spreads. The input pin is the spread, so I can connect it. The bin size is okay. And the index, well, it's the first slice and we start counting with 0. So the index is also good and we're good to go. So now you see here in the output, we only got 1 slice. So once again, I can make a connection, middle mouse click, and I got the one value I want to see. Now I can name it here in her inspector, so we know what value it is. I'm gonna name it pot meter. Okay, let's look again what happens if I turn the pot meter. The value goes from 0 all the way to 1023. So to make it usable in VVVV, I want to map it back to a value between 0 and 1. So let's make a map node for the pot meter. Map value. And we're going to connect it to the input. Well, the source minimum is 0 of course, and the source maximum in this case is 1023. The destination minimum is 0 and the destination maximum is 1. So here we have one mapped value. Okay, super, awesome. Now we can do anything we want with this pot meter. So let me quickly rotate a quad for you guys. I need a renderer. Select the renderer and hit Alt-2. You dock it. And let's move the renderer over here. Make it a bit bigger. I want a quad, of course. Quad DX9 for today. And I want a transform 2D. And we're going to connect the transform to the quad. And now I can hook my mapped potentiometer value to the rotation pin of the transform node. And if I now play with my potentiometer, I am rotating the quad. How cool is that? And if you want, of course, you can hook up 5 more analog pot meters and control even more parameters. But next, let's look at the digital inputs. These can be simple things like buttons and switches. I have a very basic tactile switch. It requires a 1000 ohm or 1K resistor to pull it down to the ground. And this little button will give me a digital 1 if I push it and a 0 when I leave it alone. It has 4 pins, but internally pin 1 and pin 4 are connected and so are pin 2 and 3. So make sure you stick it the correct way in the breadboard. The side that goes to the resistor and the ground will also go to the Arduino. So let's pick digital pin number 2. And on the other side I connect our little button to the 5V rails of my breadboard. In the enumeration list I'm going to set the 3rd pin to be an input. So now it's a servo and now it's an input. And to get anything out of the node, I need to enable the report digital pins. So again, I make a connection, I left click, and then I middle click, and I get the I/O box, and I middle click again, and it gives me a name. So let's enable the report digital pins by right clicking on it. Since we want the 3rd slice, or slice number 2, since we are using pin number 3 on the Arduino, let me just simply duplicate this get slice node. I select it and hit Ctrl D to duplicate. And I connect my digital in to the input of the get slice. And I'm only interested in slice number 2. Put the index on 2. And if I left click, middle click, I get one slice, slice number 2. Let's try if it works. If I press on the button, I get a digital 1 over here. And if I let go, I get a 0. So now I got a pot meter and a digital button, all connected to the Arduino without writing any code. And I say this is cool. So I can name this I/O box, I click on it, and let's call it a push button. Now let me find something cool to do with this. I can make a damper node, damper connected to the push button. And if I now push my button, you will see that the value doesn't jump, but goes smoothly from 0 to 1 and back. Now we can add that to the rotation of our quad. So I make a add node, and I'm going to add the mapped potmeter to the damped push button, and I'm going to connect that to the rotation. Now my quad is still rotating according to the potmeter, but look what happens if I press the button. It rotates very weird. So this is just one of the examples you can do with push buttons and potmeters. But of course it doesn't have to be only potmeters and buttons. In the middle here I have a light sensor. It will have more or less resistance depending on the amount of light it receives. I also use a 1000 ohm resistor to protect my Arduino. And again, one side goes to the 5 volts and the side of the resistor goes to the ground and to, let's pick pin number 5. So for the output side, again, we need a get slice. So let me duplicate my potmeter and connect it to the analog in. And of course it's not a potmeter, but it's my light sensor. And since I have connected it to pin number 5, I need to put my get slice node to be slice number 5. And here you see a value. Now the output depends on the amount of light. So if I put my finger on this sensor, the value should be getting lower. And it does. And if I shine the flashlight of my phone on it, the value gets higher. Anyways, these are two examples of the analog inputs and one example of a digital input. I am not going to use the quad anymore, so I'm simply going to delete it. And let's look at some easy ways to get something out of the Arduino. Well, we already saw the servo in action, and here I got a little piezo speaker. The plus side, the long pin, goes to a PWM pin on the Arduino. So I pick pin number 3 and the other pin goes to the ground. Now, as you can see in the list here, we only got 6 PWM pins, and that's the reason I picked pin number 3. Now I need to set pin number 3 or number 4 over here to PWM. If I now change slice number 3, we should hear a noise from the speaker. I really don't like this sound, but hey, it works. And if I put it back to 0, we get silence again. Now, instead of us fiddling in this spread list, I'm going to make a set slice node, a set slice spread. So I double left click and type in set slice spreads. It is the opposite of the get slice. The spread I'm going to need is spread number 2 over here, and the output goes to the Arduino node. And now I can say what slice I want to manipulate and what the value should be. So the index is number 3. And if I play with the input, I can turn my speaker on and off. Now let me quickly make some techno for you guys. I need an LFO to give the rhythm, LFO animation, and I'm gonna put it at a period of 0.2 seconds. So that's 0.2 seconds per note. And now I'm gonna make a spread with 4 slices. So I double right click, move my mouse away, select the node, put it at calls rows pages, make it 4 rows, and now I got 4 values in a spread. And now I'm going to make a get slice, and I'm going to use the cycles pin of the LFO node to get a new slice out of this list every 0.2 seconds. Now in between every node I want some silence, that just makes it sound better. So if my LFO output is smaller than, let's say, 0.5, I can switch the get slice output to the value of the spread or to a 0. And now I can connect the switch to the set slice. You still hear nothing, so let's change some values and we're gonna make some music. And of course you can play with this if you want. I already done that, so I'm not going to. I just proved my point here that we can make music with a piezo speaker. Actually, I'm gonna delete everything. And now my speaker is quiet again. Okay, on to the next thing, an LED. I have a simple LED. This is a blue one. The long wire, or the anode, goes through a resistor to yet another PWM pin of my Arduino. So let's pick pin number 5. The other side goes to the ground. Inside my patch, pin number 5 is already set to PWM. So if I change the index of the set slice to be number 5, and now I play with the input, my LED starts to glow. Now the annoying part is that if I go past a value of 1, it will be dimmed again. So to fix that, I'm simply going to map the value. So I'm going to make a map value again. And everything that goes to my Arduino should be mapped between 0 and 1. The source and destination are already okay. I just want to change the mapping mode to clamp. And this way I will never go above 1 or below 0. So if I connect an LFO to my get slice node, to the input pin, the LED will continue to fade on. And if I add a wave shaper in between, that is wave shaper value, and I put the shape to sinus, my LED will fade on and off. Now we still have this pot meter down here, and let me quickly make the map node again. From 0 to 1023. And we can use this value of our pot meter to dim the LED. But as you can see, I am not able to connect this. So if you right click, you lose the connection. And to fix this, we're going to need a frame delay. And I also did a tutorial about this, and this is also on YouTube. I'm going to choose frame delay value. So the mapped value goes to the input of the frame delay, and the output goes to the set slice. And now I'm able to turn my pot meter and dim the LED on or off. Now we might want to not dim the LED, but simply turn it on or off. And for this we don't need a PWM pin, but a digital output. So if I put pin number 5 to be a digital output, and I now turn the pot meter, you will see I can turn off the LED or I can turn it on again. A value above 0.5 will turn it on, and a value below 0.5 will turn the LED off. So this can save you some PWM pins if you need them for other stuff. Well, this was one long tutorial, but I hope you understand a bit the power of the Firmata and VVVV. Also over here I have a little RGB LED, and this is a cool little thing that I want to keep for the next tutorial. So, thank you for watching. My name is Wesbam, and I see you all next time.